So welcome. Thanks, Gabby and Colin. Thanks coming. Thanks, Braulio. Today's the big day. It's the biggest holiday of the entire year, which is do y'all know? Pi Day, March 14th, 314. Yeah, so today's it's a big day for math, at least. So welcome to Pi Day. And this is it's not just Pi Day, but it's actually our last webinar of the whole course. So this is it. And it's actually, I think it'll be a little shorter than usual because we don't have quite as much to talk about, but who knows, maybe you'll have lots of questions, which would be great because there's plenty of time. Let me share my screen and talk about what we're going to get into. Okay, so let me just a minute. There. So let me talk about the plan today. What we'll do is we'll start out with Q&A as always. Always happy to answer questions. And then we'll get into ANOVA. That's actually, it's our last topic of the class. And it's one of those topics you're gonna feel real comfortable about probably at the end of today and the end of the week at least. And you'll think really what's going on, but you don't. Just let you know, it's much deeper than what I'm gonna be talking about. So that's a big deal. Okay. So I'll talk about ANOVA and I'll talk about the requirements. And that's one of the difficult things is, what do you need to be able to have to be able to do ANOVA? And we'll get into that. Okay. And then finally, we will get into Project 2. Just to mention it again, I've already talked about Project 2 and what's required and all that, but I want to make sure that, you get all your questions answered, and maybe I go over some of the last thoughts that you need to be sending or thinking about before you turn it in. Because your project is due on Sunday, but you really don't want to wait till the last minute, that's for sure. So that is important. Okay. Hypothesis testing for 2 parameters on 2222. Yeah, so this is a big year, I guess, right? And Pi Day today, we'll see what else comes. I think those are the big days. But let me ask you, are there any questions about anything? This is a good time.
I have a question about the exam.
Sure.
And a question on the exam. So the question was, suppose the results indicate that the null hypothesis should be rejected. Thus, it is possible that a type 1 error has been committed. Given the type of error made in this situation, what could researchers do to reduce the risk of this error? Option A, choose a 0.01 significance level instead of a 0.05 significance level. Or option B, increase the sample size.
Mm-hmm.
I thought option A would be unethical to change the significance level after performing the analysis.
Yeah, it was probably talking about what would you do after. The idea is if you were doing another study.
Okay.
So if you're doing another study, so in other words, you kind of throw out your study.
Yeah.
And you start over.
Okay. Yeah, that makes sense.
And if you start over, then you can, because you haven't looked at your data yet for the new data.
So you get some new data.
Yeah.
Okay. Well, in my opinion, the question didn't really make that clear, but that's okay.
Yeah. So you can get some new data, and with new data, you can actually, change your level of significance.
Okay.
Yeah. So that's kind of always the options. Okay. Otherwise, it's pretty impossible. Yeah. Yeah, because you're not, again, as you said, you can't change your level of significance after you've already conducted the hypothesis test. Because again, there's bad ethics about it. Doesn't mean people don't, but people do all kinds of bad stuff. Yeah. Other questions? Yeah, and I want to remind you guys, and those who are listening, everyone gets a different exam. It's a whole lot of randomized questions. So if you don't know what he just talked about, then that's because you didn't get his exam. Okay, and it's not like I don't actually pick at all. It's all randomized by the computer. So it's just, there's no, favoritism or anything like that going on. There's luck, I guess. Yeah, and in terms of the exam, my goal is tomorrow I'll have it graded. Today, as you probably saw, I graded the discussion posts. And I can only do so much because today I teach all day long. So tomorrow I'll have your exam graded. And I noticed you sent your project. So again, I've been teaching all day long, so that'll be tomorrow also. Today's a really busy day. It's 8 hours of teaching. So it's a long one. Other questions? Other questions? Okay, if there aren't any questions, I just want to remind you, you can always ask as we go. There's no, it's not like we can only do questions now, but I always like to start it. Is it called a t-test or a t-statistic? Because it uses the t-distribution. Yeah, so the reason why we use the letter T is because it uses the t-distribution, whether it's the test or the statistic. So that's the reason. Okay, so anything that uses a t-distribution is a t-test, but then you often give a little more information than just t-test. Like, in terms of the real world, you say t-test using it for regression analysis, or t-test for a single population mean, or t-test for the comparison between two population means, with dependent data or with independent data. So there's a lot of different t-tests. So usually you give a little more information, if that makes sense. Because T is kind of, T and Z are the biggies, although there are others. What's the other one? What are the others that we've had? Because it's good timing. What other distributions have we had besides T and Z? Z was normal distribution. T is what's called student's T distribution. Yeah, we had the chi-squared. We had the uniform distribution. Okay, I'm guessing your U meant uniform. And then we also had the binomial distribution. Okay, so there's a lot of distributions. Today, we're actually going to do a different one. Yeah, the textbook, in a few places, I try to get rid of the exponential everywhere I could. There's a lot of other distributions, so we don't go over exponential or any of the other 100 different distributions there are, but we do have one more, and that's today, and that's going to be what's called the F distribution. Okay, and it's just another distribution. So that is the plan, but we need to talk about what kind of hypothesis situation haven't we dealt with yet? Any thoughts? Like, we've been able to compare two means, we've been able to compare two proportions. We could look at, a regression analysis hypothesis. We learned how to look at qualitative data using chi-squared. If there were many different yes, no's, we were able to do that using chi-squared to see if there's a difference in distributions. 3 or more independent groups, but what kind of groups? So you're right, 3 or more independent groups of what type? Quantitative. Okay, so that's what's left. Okay, that's the main thing. That's the one thing that's left in our class to be able to do the things that you would think about doing. And that is, what if you have more than 2 different groups, okay, that are independent, and the survey question is quantitative. So if the survey question is quantitative and you have more than, again, if you have more than 2 groups, then you can't just use a t-test for a difference between 2 means. Does that make sense? So you can't just use the t-test for difference between means. I'm gonna mute you because it's really noisy, but unmute if you have a question. So you can't use a t-test for what's wrong with instead saying, well, let's say you had, you wanted to see if there was a difference in how about average height in the states in America. Okay, so you might know how many states are there in America? You might not know. I don't know. Yeah, it's 50 states in America. Okay, so you could say compare California and Pennsylvania, and then you can compare Nevada and New York, and then compare Texas and Alabama. You compare them all. And if you find a difference, then you say, you know what, they're not all the same. What's wrong with that? Any thoughts? Any ideas what's wrong with that? There's a big problem with doing that, what I just said. And you have a computer, so it's not a time issue because computers can go through fast. Okay, so you may not be able to come up with it, but okay, I first did California and Pennsylvania. And let's say we used a 5% level significance. Then there's a 5%. So let's say they're all the same. Then on that first comparison, there's a 5% chance that you can end up with the type 1 error. Okay. And then you compare New York and Alabama. Well, there's another 5%. And then you compare Texas and Alaska, another 5%. Okay. There's actually thousands of comparisons you can do. Okay. Huge amount. Okay. And if each one has a 5% chance of a type 1 error, you're going to end up with a type 1 error. And you're going to end up deciding that they're not all the same. So that doesn't work. So what we need to do is we need to come up with a different way. So, and the way is going to be what's called ANOVA. And ANOVA corresponds to, let me show you, because I got it written out. It means analysis of variance. Okay, and I didn't accidentally spell it weird with weird capitals. That was on purpose because the AN in analysis, the O and of, and the VA in variance get put together, and that becomes ANOVA. And that's why they call it ANOVA. I have no idea who came up with this and why. Okay, but they did, and this is what we use. So everyone calls it ANOVA. And we're only going to do what's called one-way ANOVA. I can't get into all the complications. But what it does is it tests to see if several means are all equal or not. So H naught, I'm going to write with symbols. And that is mu1, the first mean, is equal to mu2, which is the second mean, right? If we were doing all the states, we'd sit there all day long. So you usually use ... if there's a whole lot of them. And that just means keep going until you get to the last one. And that equals to mu(n), the nth mean. So if we're doing all the states, that would n would be 50. Okay, so all depends on how many things you're comparing in terms of how far you go. Okay, so if there's 50 means, just one of them need to be different. Okay, yeah, so if there's 50 means and one is different, then that's good enough. Okay, so what is the problem? So you're looking at H1, but I haven't gotten to H1 yet. Right now, H naught is they're all the same. What's the problem with just saying mu1 not equal to mu2, not equal to mu3, not equal to ... not equal to mu(n)? It's kind of what you said. Okay, so if you just, in symbols, change all the equals to not equals. Why is that not right? Yeah, most of them probably are equal. Probably is not the important word. What matters is that in order for H naught to be false, all it takes is two of them to be different from each other. And if two of them are different from each other, then they're not all the same. Do you agree? Okay, they might all be different, but all you need is two of them to be different. You don't need them all to be different, because the contradiction to they're all the same is at least two are different. What I have found in my long time of teaching is that if I tried to write H1 in symbols, or when I used to do that, nobody understood it and everyone got it wrong on the test. So I gave up, and I've learned that I just do it in words because that works. The symbols are really messy. And instead, what I recommend, and this is what you need to do, is H naught will always be, you list out all the mu's, and if there's only a few of them, you can list them out. If there's a whole lot, you do the dot, dot, dot. Okay, and often you subscript with whatever makes sense in terms of like the first letter of what it corresponds to, something like that. So it's just in general. And H1 is at least two of the population means differ from each other. Any questions on that? Any questions? Okay, so one of the things that you might say is that just like some of the others, what do you need to be able to use this test? So one of the things you need, of course, is quantitative data. You're comparing several things that are quantitative. Okay. Yeah. Normality or a huge sample size. Yeah, but it's not just huge sample size. You need to make that plural. Yeah. So let me go through. It's actually more than that. It's a whole lot of things. So here's the requirements. This is what you need to be able to use ANOVA. The first is all sampling distributions are approximately normal. So if we were doing the 50 states, for example, and we wanted to find out if, I think what I say, heights were all the same, something like that, average height. I have no idea if the average height in Texas is normally distributed. Okay, not to mention Pennsylvania or Kansas, or you name your state, Minnesota. So you'd have to go through and you'd have to know all the states had a normal distribution, and that you can't, you pretty much never can. So instead, you make sure all the sampling distributions are approximately normal. So if you were doing the states, then the idea is you don't have to have them all be normal, the states, because you can let the sampling distributions all be normal. So what do you have to do and make sure of in every state? Yeah, each state has to have more than 30, 31 or more different people that you surveyed. Okay. And that could add up real fast, by the way. If you're doing the states, that's a lot of people. Okay. If you were doing maybe 3 different categories, that's not too bad. But if you're doing, 50 categories, that could take a lot of work. So that's just a note. There's a lot of stuff that makes this kind of a tough one. Okay. Number 2. All the population standard deviations have to be equal or approximately equal. And I will tell you a couple things. One is that we do not have the tool yet to compare multiple standard deviations to even know if they're equal, right? Because all we have is samples, right? So that's a problem. The other is approximately equal. It really depends on the sample sizes, and I'm not going to get into the details, but there's certain situations with sample sizes where you have to be more equal than others. And this is what my promise was, is that you're not going to know everything about ANOVA by the end. Right now, we're just going to say, here's one of the things, just buy it. Does that make sense? Okay. Then number 3, probably I should have made number 1 actually, because we started out our whole class like this. If you ever have bias, then you can't do anything in this class in statistics. Okay. So if you only looked at basketball players in Utah, and then you only looked at elementary schools in Kansas, you got some real bias when you're doing heights for each state. Okay, so one thing is, you got to make sure that you don't have bias. Simple random sampling, which is usually impossible. So what you do is you do your best to try and control it. so that you have at least representative sampling using, stratified sampling with multiple methods, all kinds of things. That can get really hard. And we've talked about it. It's no different really for ANOVA than it is for other things, but it is usually the hardest thing. Because as you might guess, how are a lot of surveys done nowadays? There's really a couple ways people do surveys. Electronically, online. And if you're doing heights of people, well, that's a problem. One thing I said, people. How many infants are going to be answering your survey question? You see the problem? Okay, yeah, 0. All kinds of issues. So having simple random sample or no bias is very difficult. So what you usually do is you do your best to limit the bias as much as you can, and then you live with it. And you say, well, it's good enough. Okay, to get no bias is almost impossible, but you can do your best to kind of restrain the bias, make sure it's not too bad. Okay, and that's why on your projects, which we'll talk about again, on project 1 especially, because that was a big part of it, if you said there was no bias, good luck, you're not going to get all points because there's no way. And project 2 is pretty hard to get no bias also. Okay, and if you're ever going to do a survey where you're asking people and finding people, that's like impossible. But maybe you can limit it using good stratified sampling, etc. Okay. You need to mention bias in the paper. I will talk about that in a bit, but you don't have to get deeply into it. Okay. Number 4 is the samples are independent. Okay. So that is, important. So that's the kind of thing where you can't ask a person 7 questions and compare each person's 7 answers, because that would be dependent. Okay. This doesn't mean you can't do statistics if you have multiple, if you have like, a bunch of dependent data sets. It just means that you need to take another class in statistics to learn how to do it, because we can only do so much in our class. And so we're only going to go to the independent samples when you have multiple samples. There are ways of doing dependent samples, but we can't do that today. Okay, or ever in our class. Okay, so they must be independent. Okay, that's not very hard, for example, if you're doing heights of states in people and states, because you're probably not going to have any dependency between the people you ask in Maryland and the people you ask in North Dakota. Okay, they're probably going to be independent. So a lot of times that's easy. You just have to be aware of it. Okay, and then finally, the samples were consistently taken. Do you know what that means? Any thoughts? Okay, same time might be important. Okay, may not be so important for heights of people if you're doing that. But let's say you did it. Let's say instead you surveyed, instead of heights of people, let's say you said on a scale of 1 to 100, with 100 absolutely thinking he's great, and 1 means he totally sucks. How much do you like Biden? And if you went from state to state by yourself, and this month maybe you went to California, but then if you're doing it yourself, it's going to take a long time, so maybe you didn't get to New Hampshire until November of this year, then the country is probably going to change a little bit, you know what I mean, and attitudes kind of change. So that would be a big problem if you waited time-wise for something like that. Heights of people probably wouldn't make a difference if you waited between now and November, and heights of people in states. Does that make sense? But there's some things that do matter a lot. Other things about consistently taken, and I think I mentioned that I used to work for a market research company. One of the things that we did before we started our, remember I was only 11 years old, but they treated me like an adult. It's kind of weird. But one of the things that we did is before we started calling people, we had a meeting. There was a group of us that was calling. And the meeting was to let us know so that we were all asking the same question in the same manner, responding in, to any questions about it in the same way, to make sure that every person surveying consistently conducted the study. And so, for example, if you're going to do it in the 50 states, then you're probably going to hire people possibly in each state. Okay, it's going to be very expensive, but that's what you're going to do. And then, especially if you had to do some face-to-face survey. So you're going to have them meet together to make sure that everyone is on board with the same way of doing the survey. Okay, so time could be one issue. Another, again, is you could have multiple people doing the survey, and you want to make sure that they're all doing it in the same manner. Any questions on that idea? Okay, and if any of these are like off by a lot, you can't do ANOVA. Okay, you can't do ANOVA. Okay, so if your distribution, the sampling distributions are not all normal, then that means you probably need to get a bigger sample size. Okay, if the standard deviations are not equal, that means really you need to take another statistics class. So you can learn what to do with that, because that's pretty complicated. That's all I can tell you about that one. All right, if you have a lot of bias, you should never publish it or use it for anything because it's worthless. Might be fun, but that's about it. So bias is bad. Okay. If the samples are dependent, you take another statistics class and you learn which test to use for dependent data. And if the samples are not consistently taken, then you need to start over again and make sure you redo it with your consistent samples. Any questions at all on the requirements? Okay, these requirements are required. Okay, if you miss any of them, it's bad. And it's hard. Okay, again, we're going to do everything in theory, so it all sounds good, but in the real world, everything's different. Any questions at all on this, what ANOVA does and what the requirements are for ANOVA? All right, so let's look at an example. Okay, so here's the example. Suppose a study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. The data from the study is shown below. Okay, by the way, do you remember what it means if I say suppose? Yeah, it means I totally made up the numbers. This is just for our class. Okay, so don't go and quote me about the results. Okay, but you could imagine a study being done, I hope, right? Well, you survey people and you ask them what their race is and how far they live from the nearest public library. That could happen. Okay, so here's the numbers I put in categories. We have white, Black, Hispanic, and others. And here are the numbers I've got. Okay, so you'll notice that we surveyed 6 white people, we surveyed 4 Black people, 6 Hispanics, and 4 others. By the way, is it a problem that we didn't survey the same number of people? Okay, let's take a look. The sample sizes being the same is not important. You don't have to have the same sample size. It's not important at all. So that's not a problem at all. Same thing when we had independent sample t-test. You could survey, 50 people, 50 men and say 60 women, and that's fine. Does that make sense? Or 100 college students and 500 non-college students and survey them and compare. So not a problem to have different numbers. There's no issue at all. Okay, so that's not a problem. Consistently just means that you better ask the same survey question. You better, in terms of how you ask, how far you are from the nearest public library. Okay, and what information you give. Are you going to hand them a map? Things like that. Those are the kind of things you have to make sure of. All right, so what assumptions must you make in order to perform a ANOVA test? So let's answer that. So I think the best way to answer this is to go back. Here's our requirements. The sampling distributions are approximately normal. Do we need to make that assumption? Yes, because look at the sample sizes. They're small. Okay, by the way, even if 3 of them were over 30 and 1 wasn't, then you have to assume that the one that wasn't over 30 has an approximately normal distribution, where the other ones you know about. So the sampling distribution for each of the 4 races is approximately normal. Any questions on the first one? Okay, let's go to the second one. That was all population standard deviations are equal. Is there any like knowledge that we've got that they're equal so we don't have to make that assumption? No, so we better assume that. So the 4 population standard deviations are approximately the same. Any questions on that? Okay, let's go to the third one. Simple random sample, no bias was done. Okay, based on what this said, study was done. All it says is that. Do we know that there's no bias? Yeah, there might be some bias. There might be no bias. We don't know because it didn't tell us. And if it didn't tell us, then we need to make it as an assumption. Do you see that? Maybe they did a simple random sample. It doesn't say how it was done. So there was no bias in each of the 4 samples. Okay, let's look at number 4. The samples are independent. Are these independent? We can't say for sure, but most likely. This kind of survey, it's not the kind of thing that it would be dependent. You survey a bunch of people and you ask them, what's your race and what's your, how far are you from the library? So there's a small possibility that independence, that they weren't independent. But most likely, independence is not an assumption needed. Right? Because we're not talking about some kind of paired, or data where you have some relationship between these people. That would be very weird. So probably you don't need to make that assumption. Any questions on that? But it's good to say just in case. But most likely you don't need to worry about that one. Okay, the samples were consistently taken. Do we know that? We know they're consistently taken. Does it say anything about it? Yeah, this one is we don't know. So we probably need to make that assumption. The assumption of the samples consistently having been taken is probably needed. Okay. So kind of ways you can go wrong with this kind of thing is if you went to like neighborhoods where you knew that you had a neighborhood that was mostly Hispanic, and then you went to another neighborhood where you knew it was mostly Black, and you went to another neighborhood that you knew was mostly white, and you went to another that was mostly, of other races, then the consistency is not there. Because as soon as you go to that neighborhood may have a library, it may not. Do you see that? So that would be one you have to be careful about. So I'm trying to make this real world, and that's how the real world would be. Okay, so that's the first question. Second question, show all the details of the ANOVA test. State your conclusions in the context of the study. So let's start out with the hypothesis. So I'm going to write H naught. And what we're going to have is mu sub, and let me remember the order, white, Black, Hispanic, other. So sub W is equal to, and just to make it easier to type, I'm going to do copy and paste, is equal to mu sub, second one was Black. The third one was Hispanic. And the fourth one was other. And I'm going to make this bigger so you can see it better. Any questions at all on H naught? Any questions? Okay, so just a note. Now we're going to do H1. And again, this is the first time H naught and H1 look totally different. The H naught we're going to do in symbols, H1 we're going to do in words. It's just too hard to do it symbolically. Any questions? So H1 is at least 2 of the population mean distances from the library or the nearest public library differs and maybe I should say at least 2 races, 2 of the population mean distances from the public library differ by race. So it might be Hispanic and others might be different in terms of how far they are, or it might be whites and Hispanics. It's just any of the 2 if differ, then that means they differ. Any questions at all on H naught and H1? Any questions? So again, I want to let you know, H naught is symbols. H1 is words. And in chapter 11, remember they were all words. In chapter 12, all symbols. Chapter 9 and 10, all symbols. So now we're half and half. Symbols and then words. Any questions at all on the hypotheses? Okay, so the next step, usually you want to state the test we're going to use. So use an ANOVA test. And I want to give you a little bit of a warning. Remember, ANOVA stands for analysis of variance. And you look at the hypotheses, are we comparing the variances? Is that what we're doing here? Yeah, we're comparing means. So this is where I know it can be confusing. And it's like, almost feels not fair that we call it analysis of variance when we're comparing means. Doesn't that feel bad? So the only thing I can tell you is trust me that the mathematics, the deep mathematics behind this involves variances. That's all I can tell you. I can't get into it, but it involves variance. So you don't have to know anything about that. All you have to know is the title, analysis of variance, and that H naught is that the means are all the same. Mu sub 1 or mu sub W equals mu sub B equals mu sub H equals mu sub O. And H1 is that at least two of the population mean distances from the nearest public library differ by race. Okay, so that's the old trust me, that it's not like named analysis variance to like trick you. It's named it because in the deep mathematics, that's what they do. Any questions at all so far? Okay, something like this. What do you think a good level of significance would be? 0.1 might be okay, but it's not probably what would be used. Any other thoughts? Point 0.01, one more guess. Yeah, 0.05. This is sociology, right? You look at races and how far people live. I don't think I've ever seen a sociology research paper use anything other than 0.05. So that's just standard in social sciences to use 0.05. So since this is social sciences, certainly, hopefully you see that. So this is a social science kind of question. This would be using 0.05. We're not going to get into the different errors and stuff, but 0.05 for sociology kind of thing is pretty standard. Okay, so let's use (0.05) for the level of significance. Okay, what's the next thing you do always after writing down your H naught and H1 and looking at the level of significance? What comes next? Yeah, time for the calculator. So here's the good news. Let me go to the calculator. And where are we? What do you think? This should be obvious. Yeah, the last one. This is the last statistics we're doing in the class. We're done after today with the new stuff. So I'm going to click ANOVA. And what it says, we coded it this way, is enter the data values separated by commas. Okay. Then we're going to hit calculate and we'll get the statistic. So let's do it. We got to go back up here. So we have 15, 4, 11, 9. Three, 2. That was for data 1, or in this case, the whites. Then the blacks, or data 2, were 12,166. And then for data 3, 9,17,5, 14,7,1. Just come 5, 9,17,5, 14,7,1. And then data 4, those were the others. And they were 18, 11, 2, 8. Any questions at all? Any questions at all on using this calculator? Okay. Notice when I coded it for 8 possible data groups. So you can't use this if you wanted to do the states, because there aren't 8 states in America. There's 50. So that wouldn't work. Any guess on what you'd have to do if you want to do the states? No, 8 at a time won't work, actually. It's a good try. Yeah, you have to use some other statistical software. For example, the Google Sheets that I wrote. That's spreadsheet. You're going to need a spreadsheet based. So if you're going to have to do something with, many, many more, then use a spreadsheet based software package. You could pay for a package too, if you want to, spend money. But I tried to make sure that the spreadsheet one does everything we need. Yeah, R is free, but you have to kind of know a little bit of programming for that. So R is definitely more difficult to use for most people. So yeah, R is definitely free, and R is not really a statistical spreadsheet program. R is a programming code type thing. So R is more for me. Okay, but there are a lot of applications that use R on spreadsheets, that's the easy way to go if you don't want to have to code. Okay, but we're an example. We only have 4, and I would never ask you more than 8 in a test or a homework question type thing, because that's just tedious. Do you agree? And my point is not to get you to see whether you're can sit there all day long typing numbers in. That's not my goal. My goal is to help you understand statistics. So instead, we're going to hit calculate. Okay, so a couple things. Here's something we have not seen before. And that's F. And by the way, this is not a letter grade. Hopefully you haven't seen that either as a letter grade, but F is the statistics that is used for, it's the F distribution, but everyone uses capital F. I have no idea why. I don't think I've ever seen lowercase f used for it. But F is the distribution that's used. And I got time, so I might as well go to it. To our book. Let's go to there so I can show it to you. Get there in a minute. So if you go to the textbook 13.3, that's the chapter we're in. I did a little coding. I thought I did. Let's see. Maybe it's not there. Don't think it was there. No, maybe I didn't code the F, but the F is another distribution. Try it right there. There may not be any pictures. Sorry about that. But the F is another distribution. There's degrees of freedom. It's pretty intense when it comes to the coding. But you don't have to worry about that. All you have to do is know that if you click on the statistics calculator, that F is shown, and that is test statistic. So if you want it for decimal places, it's 0.3339. And P, at this point, you should know what that means now. I think it's 13.4 facts about the F distribution. Oh, maybe I did have the wrong one. Yeah, I thought I had coded it. Sorry about that. Oh yeah, there it is. I knew I did it. So it turns out there's two sets of degrees of freedom, the numerator and the denominator degrees of freedom. And this is what it looks like. So you can look at this and you can see that it's pretty much a skewed right distribution. Do you see that? It's definitely unimodal, not normal. And depending on the degrees of freedom, you get slightly different looks of it. But there's our distribution. Okay, so just like all the others, we don't do much with the shape of the curve or anything, but I figured I'd show it to you. So thanks for finding it. I had forgotten that I put it in that particular spot. Okay, the p-value, on the other hand, that one you do have to completely understand. Our p-value, I'm going to use 1 decimal because that's enough in this case, is 0.8. What does that tell us? So P is 0.8, which is much less than 0.05. So all that work to think about what our level of significance was, we didn't even need to because it's so high, our p-value. In the real world, a lot of times you don't pick a level of significance. You get your p-value and then you just use that vocabulary I talked about. So either you have strong statistically significant evidence, you have statistically significant evidence, you have weak evidence, or you have no evidence. Remember, those were the kind of 4 categories. Strong meant less than 0.01, just regular means between 0.01 and 0.05. Weak is 0.05 to 0.1, and bigger than 0.1 is just no evidence. And here it's very much no evidence. So there is statistically insignificant evidence to make a conclusion about whether there is a difference in the population mean distance people live from the library based on race. Another way of saying it is there is statistically insignificant evidence to make a conclusion about whether race is a factor in distance to the library. Any questions on that? Those are equivalent, but I figured I should show you the way a lot of people say it. And a lot of people say that the H1 is that race is a factor in distance to the library. Okay, so whatever the categories are, is that a factor in what the mean is that you're looking at? So you'll see that often in terms of research. Okay, just to talk about this a bit, what if instead we got, instead of 0.8, what if instead we use a calculator, we had different data, and let's say you had 0.02. Then you could say there is statistically significant evidence that race is a factor, or at least two of the population mean distances from the public library differ by race. So let's suppose we did get a low p-value. Could you then go and look at these, and based on what we just got from the ANOVA, if we got a low p-value, say which are the two that are different? Yeah, so did I say less than? Did I say greater than? Yeah, greater than, not less. I'm just looking at your comment. Yeah, so which of the two are different based on, can we decide which of the two are different using ANOVA? Any thoughts? If we had gotten, say, a 0.01 p-value or 0.02 p-value. Okay, the answer is no. Okay, you cannot decide that using ANOVA. So if you do want to figure out which two are different, what do you have to do? The hint is we're in the last day of our class. Yep, take an upper division statistics class, and you're going to learn about Tukey analysis. There are other tests to go beyond this. So like I said, I'm just giving you the very basics of comparing many means. And the very basics is you can use ANOVA to say that there's at least something's different. What you can't use ANOVA for is to decide which ones are different. That is done with another test. Tukey's one of them. There's some others too. There's all kinds of, there's a lot of tests and stats that we don't talk about. But I do want to, give you a heads up that if you needed to, then you need to, get some help. Any questions at all on ANOVA so far? Okay, just to know, I don't know if I mentioned it. You remember after in 2 weeks when this class is over and you need help with stats, remember my offer? Did I tell you my offer? If you're doing it for your research as a student, then just ask me. I'll help you out. I would never charge you. But be ready for Kleenex in case I have to tell you the bad news that your sample size is too small, because that happens sometimes, and it gets ugly. I have to let the person know that your thesis is really not appropriate because your sample size isn't big enough. Okay, and then they're like, well, I don't have time. It's like, well, you asked me for stats help, and I have to tell you the truth. So you make sure you have big enough sample sizes. But then let's suppose that you continue on, you finish your college and you get a business, and now you want help with statistics for your business. Can you ask me? Okay, the answer is yes. And are you going to have to pay me? The answer is no, but I'm going to want you to give money to a scholarship fund so that you can help our students. So that's my rule. So that's as long as, I'm around, my email probably won't change for a very long time. So that'll help. And I have helped a lot of people, and we have scholarships, which is nice. So just let you know. So if you have a business, then I do want you to support students. That's my one request. If it's for your own education, that's a whole different thing. I'll help you out. Once a student, you're always my student. But once you're not a student, then you're a business person, and then I want you to support. Okay, so this is ANOVA. And again, they're all kind of look similar, the examples. I mean, they're not about race and distance from library, but you're going to have categories. It's going to be a quantitative survey question. And you have to use ANOVA to be able to decide whether the means are, at least two of the means are different from each other, or if one is a factor in the mean. So that's pretty much it in terms of the material in statistics for elementary stats. Okay, that we've now had a lot of different tests. So what I want to do now is I want to let you know of, any guess? Yeah, the secret word. So the secret word is thank you, because I want to thank you for everyone. Actually, this is a good class. I haven't had any like just evil people. That's always a nice thing. It sucks when an evil person comes in, but you've been all at least polite and all that, you know. And so this is thank you, and that's the secret word. And I want to mention a few things now that we're done. We're done with every piece of statistics that's left in this to do. And for some of you, you might have been taking math like most of your life. This could be the last bit of math you ever do. Okay, depending on where you are. Okay, you might do more, but for some of you, this could be it. Okay, since you're in kindergarten, you've been doing math, some of you. Okay, I want to remind you about the course. And this is my first time ever doing it this way, the class. I'm trying something new, and it seems like I haven't had any complaints yet. But I want to remind you that we actually don't have a regular final exam in this class. Even though I call it final exam, every exam is worth 80 points. It's not like there's some exam that's worth so much more than the rest. So just to let you know that you will have an exam, and that exam is due by, I believe, Wednesday. Not this Wednesday, sorry, in 9 days from now. And you'll see on Canvas, in fact, I think it says, if you go to the very bottom, yeah, Wednesday, March 21st. And that's the end of the course. So I want to remind you of a few things. One is when March 23rd happens and you've taken your exam, do not send me an email saying, what could I do now to get more points? Class is over. So once the class is over, that's the end of points. Okay, so there aren't like big extra credit assignments or anything like that. And this exam, I call it a final exam, but it's not like any normal final exam because it's not really a lot of points. It's a very small part of your grade. So I'm trying this new. I haven't had anyone complaints yet. That's maybe that's a good thing. But if you do have suggestions, I'm always happy to take it, especially with this new thing I'm trying, which is not having like a final exam that's 40% of your grade, which is what I used to do. Now you have just incremental exams throughout the quarter. The bigger thing actually is that other than the final, and the final is less important in terms of points, is the project. So project 2 is due Sunday, March 20th, I meant. So it's March 20th on Sunday. You prefer it? Good. So far, again, I haven't had any complaints. I think I'm going to continue doing this. I teach this class every quarter. So it's my first time trying this. This is new to me. Okay. And good. So I'm glad. So far, everyone seems to be happy with it. So the project is a biggie, though, but that's different than an exam because you can get help with it and you're working together. So that's project 2. And I know, although I actually one person, I don't know who you are because your screen just has a bunch of capital letters that don't really tell me who you are, but I know the others have submitted. So I got your project draft. Let you know that Mondays are brutal days for me. So it'll be tomorrow that I read it. There's no way I can get anything done on Monday because I teach all day long on Monday. It's actually today where I teach at night too, like right now. So I've been starting early morning, and I did some grading and early at like 3 in the morning. I think I woke up, or 2 or something. Today's not your last day to submit your drafts. Your last possible day to submit drafts, Thursday at 8 in the morning. But it's a first come, first serve. So if you submit sooner, then I can guarantee that I'll get it back to you pretty soon, and you'll have more time to work on it, because it's due on Sunday. I recommend trying to get it in by Saturday. That way, if anything goes wrong, you get an extra 24 hours. That's just a good, whenever you have anything important, that's just a good life skill, is always trying to get a little bit earlier so that you've got that just in case extras. So again, I recommend by like Wednesday, not so late, to send it to me. If you already sent it, that's great. Tomorrow is when I'll look at yours. I've already looked at one and sent the feedback for the projects. I want to remind you, just like project one, but for some reason, a lot of people don't pay attention to it. Who's the audience of your project? Yeah, the client, okay? The client, okay? Right, so if it's President Biden, the audience is President Biden. And of course, it's all imaginary, because President Biden's, by the way, probably won't really read it, but you could pretend, okay? Journalist for a local magazine. So the point is, you want to make sure that everything you write about specifically talks about the client's needs. And there's a lot of things you're writing about. The main things you're writing about in terms of the statistics, the standard error. So write about how the client will react and make decisions after seeing the standard error. Okay. What damage might a type 1 error do to the client? What damage might the client have based on a type 2 error? Based on the damage to the client, what might the client decide for the level of significance? Okay, so what you don't want to do is just write down the standard statement to interpret the p-value. You could start with that, but then talk about what the client is going to do after seeing that p-value, and what decisions or reactions might the client have after seeing it. Does that make sense? And after looking at all 3 confidence intervals, 90, 95, and 99, which is going to work best for the client and why? And there's going to be pros and cons for the client. So make sure that the client is the person that you're talking to, writing to. The only thing that you can do that may not be quite correct is you can assume the client understands statistics. I actually have no idea whether Biden understands statistics or not. I actually don't know about that. He might. He seems like a bright guy, but I have no idea. He's educated, but I don't know if he's had stats. But you can assume he has. Does that make sense? Okay. So you can assume that he knows a little bit about stats. So any questions on that? Because most of my comments are, how will your client react to blah, whatever it is that you might be talking about. So try and fix that before you even send it to me. Does that make sense? And make sure in your draft you have that. And then I can do the small things instead of the big things. Any questions at all about anything? Like I said, we're a little bit shorter than usual, and I promised that we would be because we had less to talk about. I think I'm going to stop my share, and I'll even stop my recording. But those who are watching this, thanks a lot for the whole course. And I will just let you know, for those who are watching this recorded, I'll be checking the Q&A board, and I'll be checking the discussion board very often, the Project 2 discussion board often. So, and I'll be looking at my email too. But remind you, after a week from Wednesday, the course is over. So then you can send me emails, but don't send me an email. What can I do now about my grade? That nothing really. Pray maybe, I don't know. But you can't do anything after that. But you can send me emails that you have some project you're working on in chemistry and or whatever, psychology, that I can help you with. So I'm going to stop the recording. So thank you very much.